Hello, and welcome to the third episode of Chip Chat, brought to you by HCLTech Trends and Insights. I am your host, Abhijeet Sahu, and today we have a very special guest with us, Amit Roy, Associate Vice President at HCLTech. In this episode, we'll be diving into the fascinating world of generative AI or GenAI and exploring how it's transforming the chip design lifecycle. Amit, thank you for joining us.
Thank you. Thank you, Abhijeet. Thanks for inviting me in this podcast. And I'm very excited to dive deep in GenAI and to see how it can transform the chip design cycle, its own opportunity and challenges. Let's start. I'm very excited to be here.
So, Amit, before we dive into the technical stuff, I have to ask, it's been a dry summer, and just like the weather, the tech world is heating up with all this talk about GenAI. So, how are you feeling about all the buzz around GenAI these days?
It's real. It's very real. GenAI is going to transform the way we human used to work. It is definitely going to help us in accelerating our work, routine and mundane work. But having said so, there's no fear at all that it is going to replace the job. In fact, it is going to help and bring much more design efficiency, much more time to market, much more time to value. So definitely, GenAI is going to help us in doing our daily job. So nothing to fear. It is actually a tool which humankind will leverage upon to bring a better world to us.
That's great to hear, Amit. So now let's get into the heart of our discussion, Amit. So can you start by explaining like what is GenAI and how it differs from the traditional AI?
hmm That's a good question. GenAI, as the name suggests, it's called generative AI. And how it differs from traditional AI is that it has the ability to create various content like text, images, design, codes, chip design like Verilog, VHDL, and unlike traditional AI model, which is basically on the classification or prediction, which is based on patterns, identifying the pattern is this cat or dog. GenAI can generate new content, generate new output, uh, maybe a chip design, maybe a new code, maybe can write a story, can write a poem for you. So it uses a deep learning model called transformer, uh, which has so this is the core crux of our GenAI, which is different from traditional deep learning AI. This has a concept called transformer, which is trained on a very large data set, and it has the ability to understand and reproduce those complex structures inside the data, and it is making this kind of a transformer plus a very large scale data set to train on it really make this model more creative and flexible than the traditional rule based or even the traditional ML system.
It's interesting to hear like how GenAI stands out. And as you mentioned, Amit, like GenAI model learns from the vast amounts of data to identify underlying patterns and generate realistic content, which makes GenAI particularly powerful for applications like content creation, design, and simulation. And I've also read that GenAI can generate new designs autonomously that you also mentioned. So
Mhm.
my next question will be like, how does that work in practice? Like, how is GenAI specifically being applied in chip design lifecycle? And if you
Yeah,
could give some examples, that would be great.
yeah, sure. I actually my past is chip designer. So I can probably give a better, I can throw a better light on how GenAI can transform the landscape of today's chip design. So GenAI, uh, it GenAI has the capability to touch every scale of your chip design, be it the automatic article generation or the early exploration of the design, from verification to pre and post silicon validation, writing the bare metal device driver, writing the hell layers, AutoSAR device driver, end to end application. GenAI can touch every area of chip design, right from RTL to GDS2 till post silicon fabrication. Post market can help generating the embedded application. It can touch every area of your chip design. Not only it can touch, it will bring a much more efficiency in the design. The way currently we are designing, it will be bringing much more design efficiency, much faster, accelerated time to market. With the help of this Gen AI, definitely we are going to see a better gross margin on our chip design, and definitely business will scale up. Every design house who will embrace the Gen AI will see the scalability in their business cycle.
Those examples really highlight the potential of GenAI, Amit. Now, speaking of the potential, Amit, like I want to ask, like, what are the key benefits of using GenAI in chip design compared to traditional methods, and how does GenAI handle the massive amounts of data and complexity
Mhm. Mhm.
inherent in chip design compared to traditional AI and machine learning approaches? And additionally, if you can explain like how GenAI learns to recognize patterns and make decisions in the context of chip design, like you mentioned, like how that differs from the rule-based system.
Mhm. Yeah, as I've already touched some of the area, the first foremost thing is speed. GenAI drastically reduces design time by automating repetitive or complex tasks. The second one is creativity and exploration. It can suggest novel architecture that human might not consider. Then it has the scalability that the particular to your question. GenAI model can handle huge data set, making them suitable for large SOC. Because when I say large SOC, they are very huge data set, and by construction, GenAI has this capability of handling a very large data set. Then it has the ability to learn from the past data. That is a very important thing. Unlike a rule-based system, GenAI learns from the past design. It can leverage upon your past design specification patterns, and this allows GenAI to generate, uh, not to generate, to generalize and adapt, improving over time and time. And one day you will see that GenAI is able to create a world class chip designer as good as a super expert human chip designer would have created. Uh, Another area where I can think upon, which is another very good ability of Gen AI, is ability of making decision. So it has this decision making ability. Gen AI uses, and because it's a probabilistic model, and the embedding, not only probabilistic model, the and the embeddings to make a context aware decision, as opposed to the fixed heuristic based rule based ML system. So overall, these are the benefits of GenAI. So to summarize, faster accelerated time to market and much better design resource optimization. This is the benefit of GenAI.
So it's impressive, like Amit, like how GenAI can handle such complexity. And you also mentioned like some of the power of GenAI, like in terms of cost reduction, improved performance, scalability, in terms of faster time to market, and enhanced innovation. But with great power comes great challenges, Amit. So can you like highlight some of the challenges that are faced when integrating GenAI in a chip design process, and how are these challenges being addressed?
Yeah, the first and foremost thing, Abhijit, is the data confidentiality. Chip design involves sensitive IPs, and sharing with GenAI tool, which is in the cloud, it raises security concern. Lots of people are very averse of not using GenAI because it means that you have to upload your sensitive data, sensitive IP on the cloud to get the output. Um, so the solution for this particular problem is the on-premises Gen AI models or a secure cloud environment like Azure provide. So these are the area where people are really exploring on-premises solution as well as some secured cloud environment where you are very much confident that your data will not be stolen or will be abused by anybody else. The second one is the explainability. So when I say explainability, Gen AI actually the GenAI decision uh, cannot be taken as 100% correct. It is because it is very hard to interpret. But having said so, academia and people who are working this are putting lots of effort to build interpretable models and to add the validation layers on those various layers of your GenAI. Then the last point is that designer has to be very cautious about trusting an AI generated option. So when I use GenAI, I always make sure that I should not take all this output of GenAI on this face value. I actually read those output, verify those output before I start taking and using in my daily life or in my production one. So these are the challenges and solutions.
That's great, Amit. I hope this will also help our audience, like how they, if they are facing any types of challenges, so they can use some of the solutions that you have mentioned. Uh,
Mhm.
now, now, as you mentioned about challenges and solutions, I don't want like the word impact to left behind. So, are there any novel applications of GenAI in chip design that you could think could be a game changer in the industry?
Yeah, this is the area where my team is working in HCL. It's a game changing area, what we call automated hardware software co design using GenAI, where models can simultaneously design hardware acceleration and generate a matching software drivers for that hardware. Another is a constraint driven design synthesis, which I am very much actively working, where designers input high level performance area and power goals. And GenAI outputs a very viable RTL architecture. So these are the two area where I think is a game changing area, and impact on the design efficiencies will be very high.
So, Amit, going deep, I want to know, like, if you can also share some case studies and success stories, like where GenAI has significantly improved chip design outcomes.
Yeah. So SCL has its own GenAI powered chip design service called Progenics, where we have actually started deploying a GenAI solution on our verification environment, on early exploration of the design, plus the pre and post silicon validation. So when I say verification, let me go back to verification. We have the ability to generate complete verification plan, test test steps, and a complete UVM test environment just by inputting the design specification. So user need not to do anything, do not need not to write. And where our Progenics is having a USP compared to our competitor is that in our tool, the ability to completely understand a design specification is where which is making our solution way apart than our competitor. And once it is able to understand a design specification, it can produce any sort of output, be it a verification plan, UVM test bench creation, assertion for formal verification, embedded C for pre and post silicon validation, writing device driver, writing AutoSAR device driver, writing embedded application are the area where we have already a workable solution, and SCL internal design team are using it, and they are seeing almost if I am not so let me be very pessimistic when I am quoting this number. We are seeing almost 50% design efficiency. Sometimes we are also seeing 70 to 80% design efficiency with our tool. So these are the real example. I'm not saying something from academia. This is something which is in use in production, and SCL designers are also using it. And we are trying to give this project solution to our client as a value added service offering.
That's great, Amit. So it's great to hear about the Progenics and how, what are the uses of Progenics and how it
Mhm.
can like produce such efficiency in terms of, like you mentioned, 50%, and sometimes it's 70% also.
Yeah.
Now, the next question is like, about adoption, Amit. So now you also we know that the global generative AI market is projected to grow significantly in the coming years. Like in 2025, the market size is estimated to be around 37.8 billion and is expected to reach approximately 1000 billion by 2034 with a compound annual growth of 44.2%. So given the rapid growth of generative AI and its transformative impact on chip design, how widely GenAI being adopted in the semiconductor industry, and what future trends do you foresee? And are there any driving factors or are there any factors driving or hindering its adoption?
Uh, when the time I'm speaking to you, almost all the design houses, chip design houses, are trying to embrace or trying to leverage the power of GenAI in everywhere, in every sector of their chip design cycle, because they know that this is a tool which can improve their time to market efficiency, which can improve their design resource optimization. I have not seen any company who is not trying to use or utilize GenAI in their daily operation. Um, what was your second question? Sorry.
So, do you feel any factors that are like driving or hindering its adoption?
Yeah, as I've already explained, yes, the data confidentiality, the explainability, and the output of GenAI is not so trustworthy. These are the three things which is the hindrance. But there are solutions. It's not that they are roadblocking, and people are utilizing and making it a much better uh, adopted solution in their design houses.
So, do you think like there can be any ethical consideration or potential risk associated with this?
Yes, yeah, there is because the GenAI is trained on open source large scale data set, so there might be some data patent infringement or some IP infringement. So that is the reason why I always say that you do not have to trust the output of GenAI completely. One senior architect or senior designer must evaluate the output of the GenAI and use it judiciously. You should not blindly adopt the output of GenAI in your design cycle.
So, Amit, like you mentioned, like you shouldn't blindly adopt what is there. So my final question before I conclude, like, what advice should you give to the chip designers and engineers who are to integrate GenAI into their workflows?
It's not an advice. It's basically, I would say that you have to use GenAI in your design cycle. Otherwise, your job will be definitely be in danger. Uh, the advice through my experience is that you should not think GenAI as a magic box. If you try to pose a very big problem, very abstract problem to GenAI, it will hallucinate, and you will start complaining that GenAI is not giving the correct output. Is because you are trying to give a very big problem. GenAI is very good in solving small problems, and then you build upon slowly. So you break your big problem into a steps. The more granular step you can take it, the better the result you will have. And then you bring, and then slowly you make your design process step by step. But very first thing is that you have to break your problem in the smallest possible way, and I can guarantee you GenAI will never hallucinate. GenAI will only hallucinate if you try to give a problem in a very abstract way. So you always know your problem, and I always say to my colleagues, to my team member, that GenAI is a tool which can only be used by domain expert. If you are not domain expert, if you do not know your problem statement, then please do not use GenAI. If you know your problem statement, if you can break your problem statement, and if you can validate the output of GenAI if you have this ability, use GenAI, because it will bring a much faster design for you. So only domain expert and breaking the problem in smaller steps is my suggestion to those people, to those chip designers who wanted to use GenAI in their design work.
Thank you, Amit. That was a great suggestion. Hope it will help all the chip designers and engineers who are actually looking into integrate the GenAI into their workflows. Thank you so much, Amit, for sharing your insights on how GenAI is revolutionizing the chip design lifecycle. It's been a pleasure having you on the show. Thank you. Thank you, Amit.
Pleasure is all mine. Thank you, Abhijeet. Have a nice day.